imagine this. You are a small country sitting next to a superpower. You do not have nuclear weapons. You do not have aircraft carriers. You do not have unlimited money. But you do have one card to play, a fighter jet that can launch from a highway, refuel in 10 minutes, and fight as a network pack instead of a single hero jet. That jet is the Saab Gripen. For years, Gripen has often been dismissed as just a light 4.5 generation fighter. Not stealthy enough. Not big enough. Not American enough. But when air forces actually run the numbers, cost per flight hour, sortie rate, ground crew requirements, and how fast you can turn the jet around, Gripen keeps showing up as the smart option, especially for countries that cannot afford to waste money or time. Brazil chose it. Colombia has now ordered Gripen E and F in a deal that combines airpower with industrial cooperation. Sweden flies it from roads in the north. And in places like Canada, planners quietly ask, what if we do not want to depend 100% on the United States for our fighter capability? To understand why Gripen exists at all, you have to go back to the Cold War. On one side of the Baltic Sea, the Soviet Union, with bombers, cruise missiles, and large armored formations. On the other side, a neutral Sweden, sitting right on the front line, knowing that if war ever comes, it may begin with a surprise wave of missile and air strikes. In 1967, the Egyptian Air Force learned what happens when your jets are parked wingtip to wingtip at a few big airbases. They can be destroyed in a single morning. The Swedish Air Force looked at that and said, "We are never going to let that happen to us." Their answer was a doctrine called BA 90, a dispersed airbasing system built around road bases. Instead of concentrating fighters at a handful of obvious airfields, Sweden would spread them across dozens of small strips, short sections of highway with hidden taxiways, fuel caches, and camouflaged shelters tucked into the forest. This idea drove brutal design requirements for Sweden's next fighter. The aircraft had to take off and land on short highway segments, often in snow, ice, and crosswinds. It had to be turned around, refueled, rearmed, checked in around 10 minutes for an air-to-air sortie, using just one technician and a handful of conscripts. It had to handle fighter, attack, and reconnaissance missions in one airframe, jacked, attack, Spaining. That JAS label is not marketing. It is the core of the requirement. By the late 1970s and early 1980s, Sweden already had serious jets, the Draken and the Viggen. But they were large, complex, and expensive. Yes, Sweden could have bought F-16s or F divided by a -18s. But that would tie wartime survival to foreign software, foreign spare parts, and foreign politics. So Sweden made a hard choice. It decided to build a new fighter that would be smaller and cheaper than Viggen, with better performance, shorter takeoff distance, true multi-role capability, and full compatibility with the BAS-90 road-based system. That impossible design challenge is where Gripen was born. From a distance, Gripen looks modest. A compact delta wing, 2 small canards, 1 engine, 1 vertical tail. Underneath that simple silhouette, it is a purpose-built machine designed to survive on roads. The most obvious feature is the delta wing plus canard configuration. The main wing is a cropped delta. It provides good lift, low drag at higher speeds, and plenty of room for fuel and stores. But on its own, a delta can be unforgiving at low speed and during landing. That is where the canards come in. These are not decorative fins. They generate positive lift themselves, supporting the nose and allowing the main wing to be optimized for maneuver and high angles of attack. Together, the canard and delta wing produce a lot of lift on a relatively small airframe. One of the key demands from the Swedish Air Force was clear: the new fighter must be able to take off and land on short highway segments, not just long, prepared runways. In winter. In crosswinds. In marginal conditions. On takeoff, the canards help the jet rotate quickly and generate lift early. On landing, they can deflect to act almost like air brakes, dumping lift and pushing weight onto the main wheels, so the brakes and tires bite hard into the road. This is why you see Gripen landing and stopping in short distances that many larger fighters simply cannot use safely. There is another, more subtle design choice: Gripen is deliberately aerodynamically unstable. If you remove the computers, it would not be a friendly aircraft to fly. The center of gravity and aerodynamic center are arranged so that the nose wants to wander. that natural instability can reduce drag and improve agility, but only if something is constantly trimming and correcting it. That something is the digital fly-by-wire system. Pilot commands do not move control surfaces directly. Instead, sensors and computers interpret stick and pedal inputs, then calculate the best combination of canard, elevon, and rudder deflections to achieve the desired motion while keeping the jet inside a safe envelope. The result is that the pilot feels a stable, precise aircraft, while under the skin, the flight control system is making thousands of micro-adjustments every second. This instability plus computer approach gives Gripen 3 big advantages. Fast nose pointing in a dogfight. Efficient, controllable flight at high angles of attack. And the ability to operate comfortably near the edge of the envelope during short-field takeoffs and landings. Look down at the landing gear and you see the road-based doctrine again. Gripen uses a sturdy dual-wheel nose gear and strong main legs designed to handle high sink rates and uneven surfaces. The tires and brakes are sized for aggressive stopping on rough pavement. Under the fuselage, access panels and line-replaceable units are laid out so that a small ground crew, working in the open, can reach what they need quickly. No giant hangars. No massive support footprint. Early in the test program, Gripen's flight control system did have serious teething problems, including a high-profile crash. Saab rewrote control laws, improved the software, and strengthened the validation process. Once those issues were solved, Gripen built up a strong safety record, especially for a single-engine aircraft operating from short, exposed strips. So when you see a Gripen sitting on a piece of highway in the woods, you are not looking at a downsized version of someone else's fighter. You are looking at an airframe whose shape, structure, and landing gear have all been tuned to answer one requirement. In a real war, we will not die parked on a runway. Under the skin, Gripen's heart has changed over time, and that evolution matters a lot if you dream about building the jet at home. The original Gripen A, B, C, and D used the Volvo RM12 engine, a Swedish-built derivative of the American GE F404. The RM12 was tuned for single-engine safety, better bird strike tolerance, improved reliability, and adaptations for cold weather operations and rough field landings. Over decades of service, Gripen built up hundreds of thousands of safe flight hours. The RM12 earned a reputation as a tough, predictable engine, exactly what you want on a single-engine fighter landing on short roads in winter. But the world did not stand still. Surface-to-air missiles grew in range and sophistication. Fighter radars became more powerful. Customers wanted more range, more payload, more onboard electronics, and more growth room for the future. Saab and Sweden needed more thrust, more electrical power, and more cooling capacity. The answer was the Gripen E and F generation, powered by the GE F414G. The F414G is a more powerful derivative of the F414 used in the F divided by a -18E divided by F Super Hornet, adapted to Saab's requirements. It delivers significantly more thrust, supporting higher takeoff weights, longer range, and, in some configurations, Super Cruise, the ability to sustain supersonic flight without afterburner. Gripen E is not just a C model with a new engine. Saab stretched the fuselage, added more internal fuel, redesigned avionics bays, and increased the number of weapon hardpoints. The result is an aircraft that looks like a Gripen, but under the skin, it is a new generation with more range, more sensors, and more growth potential. However, there is a strategic catch. Both RM12 and F414G are US origin engines. They fall under American export control regimes, such as ITAR. That means any country that buys Gripen, and especially any country that wants to build it under license, has to live inside a political envelope defined not only in Stockholm, but also in Washington. For Sweden, Brazil, and Colombia, this has been manageable so far. They accepted the trade, Swedish openness on avionics, software, and production, in exchange for an American core in the engine bay. But imagine a country like Canada, an advanced aerospace nation that might want Gripen not just as a product, but as part of a sovereign capability. If Canada wanted final assembly, local maintenance, and a serious role in export or upgrades, the engine becomes a strategic choke point. There are essentially three paths. Option 1. Accept dependency. You build Gripen E in Canadian factories, but you keep the F414G as an imported engine. You negotiate strong guarantees, local overhaul, stockpiles of spares, long-term support agreements. You gain flexibility in industrial work, but you do not become fully independent. Option 2. Deepen the engine partnership. You still use the F414G, but you push for deeper industrial participation, local component manufacture, joint export frameworks, perhaps shared authority on certain upgrades. Technically realistic, politically complex. Option 3. True independence, a non-US engine. You re-engine Gripen around a European or indigenous power plant in the same thrust class. That means new intakes and ducts, structural changes to the engine bay, a fresh flight test and certification campaign, and major software integration work. It is absolutely possible for a serious aerospace country. But it is not quick. And it is not cheap. For most Gripen customers, options 1 or 2 are enough. For any country that wants a deeply sovereign fighter line, Gripen is attractive because Saab is unusually open to sharing design, software, and production. But the engine, buried deep in the fuselage, will always be the single most politically sensitive component in the jet. If the engine is the heart of Gripen, its avionics are the brain. From the start, Gripen was designed as a programmable platform. Its sensors, weapons, and mission systems are tied together by digital data buses and clever software, with a strong focus on sensor fusion, combining multiple inputs into one clear picture for the pilot. In the Gripen E generation, that idea matures. At the center sits the Raven ES-05 radar, an active electronically scanned array developed by Leonardo. Unlike many fixed AESA arrays, Raven can be mechanically repositioned, swinging its antenna to cover a very wide field of regard. On screen, that means Gripen can keep tracking targets even while turning away or beaming a threat, not just when pointing its nose directly at them. Radar is only part of the story. Gripen E adds a modern infrared search and track system, IRST. Instead of broadcasting energy like a radar does, IRST passively watches for heat signatures, hot jet exhausts, warm airframes, and thermal contrast in the sky. In a world of stealth shaping, jamming, and long-range missiles, having a passive way to find and track targets is a serious advantage. Then there is electronic warfare. Gripen's EW suite, often associated with Saab's Arexis family, includes radar warning, jamming, and options for escort and stand-in roles. In practice, that means the aircraft can detect hostile emitters, identify them, and respond with tailored jamming techniques to protect itself and its allies. None of this exists in isolation. What makes Gripen truly dangerous is its data link. Multiple Gripens can share radar tracks, IRST contacts, and threat information in near real time. One jet can run its radar, build the picture, and silently feed targets to another jet that never turns its own radar on. The shooter can remain electronically quiet, launching missiles using off-board target data. In the cockpit, the pilot sees the result of all this fusion, not the raw chaos underneath. Gripen E replaces the older 3-screen layout with a large wide-area display and, where chosen, a helmet-mounted sight. The philosophy is simple: the jet does the heavy data crunching. The pilot makes the tactical decisions. When it comes to weapons, Gripen is deliberately open. It can carry Western short-range missiles like IRIS-T or AIM-9, beyond visual range missiles like AIM-120, and, critically, the Meteor ramjet missile, which gives it a long-reach BVR punch with a very large no-escape zone. For air-to-ground and maritime missions, it can use precision-guided bombs, standoff weapons, and anti-ship missiles like the RBS-15. Saab's message to customers is blunt: if you buy Gripen, you are not locked into a single national weapons ecosystem. We can integrate what you need. Technically, that flexibility comes from architecture, modular avionics, software designed for incremental updates, and certification processes that can bring new weapons onto the jet without rewriting everything from scratch. Gripen is not just a fighter aircraft. It is a weapon system franchise, built to be adapted, upgraded, and armed to match each operator's needs. So how does all this technology translate into the way Gripen actually fights? Start on the ground. A Gripen lands on a short road strip, slows hard, and turns off into a small dispersal area hidden among trees. The engine shuts down. A fuel truck rolls up. One technician and a handful of conscripts go to work. Fuel hoses are connected. Missiles are loaded. panels are opened and checked. The pilot takes a quick breather, then climbs back into the cockpit. For a typical air-to-air mission, the target turnaround time is roughly 10 minutes. For a more complex air-to-ground loadout, about 20. That speed is the essence of the Swedish concept of operations. Gripen is not meant to sit at a few big airbases waiting for the enemy to target them. It is meant to appear, strike, disappear, and then reappear from a different strip faster than the enemy can keep up. In the air, Gripen leans heavily on its beyond visual range tools. A typical tactic might look like this. One Gripen runs its radar, building the picture of targets and threats. Another Gripen flies, quiet, its radar off, relying on data link and IRST. The quiet jet is the shooter. When the moment is right, the shooter launches a Meteor or other BVR missile using the shared track from its partner. To the target, it may look as if no radar threat was ever pointed directly at them, right up until the missile appears. Gripen also exploits terrain. Low-level runs over forests, valleys, and coastlines let it mask behind the Earth's curvature, pop up to fire, then drop back into cover. Combined with the BAS-90 road base network, this makes it very difficult for an opponent to ever be sure where the fleet really is. In day-to-day operations, Gripen does the bread and butter work of an air force. It flies quick reaction alert, scrambling to intercept unknown aircraft approaching national airspace. It has taken part in Baltic air policing and other multinational tasks, working under NATO command and control. In large force exercises like Red Flag, Gripen's network-centric style of fighting, with silent shooters, shared sensor data, and flexible mission retasking, has sometimes surprised pilots more used to traditional radio-heavy tactics. None of this makes Gripen invincible. In a clean one-on-one, against a well-flown Refuel, Typhoon, or F-16V, it lives and dies by pilot skill and tactics like any other jet. But the design priorities are different. Big heavyweight fighters are often built around maximum performance, top speed, payload, radar power. Gripen is built around maximum availability, how often it can be on a mission, from how many locations, with how small a support footprint. In modern warfare, where survivability depends on dispersion, mobility, and how fast you can get back into the fight, that design philosophy can matter more than a few extra knots of top speed on a spec sheet. Behind every fighter jet, there is an invisible world of jigs, fixtures, and workers in hangars. Gripen is no exception. In Linköping, Sweden, Saab's home base for fighters, the build process happens in stages. Major aerostructures, front fuselage sections, center fuselage, wing boxes, tail cones, arrive from specialized plants. Technicians mount the front fuselage and cockpit tub into a fixture, then begin installing wiring harnesses, hydraulic lines, avionics racks, and cockpit displays. Farther down the line, the wing box is joined to the fuselage. Those joins must carry enormous loads in flight, so every hole, fastener, and seal is checked and rechecked. Next, the rear fuselage and tail cone are attached, along with the vertical tail and the canards. Control surfaces, flaps, and actuators are installed and connected to the flight control computers. In another area, the engine, RM12 or F414G, depending on the variant, is prepared and then hoisted into the fuselage. Fuel, hydraulics, and control systems are connected. Ground tests verify that everything talks properly. Only after systems integration and power-on checks are complete does the Gripen move to paint and finishing, and then out to the flight line for taxi trials and first flight. Now, take that mental picture and move it to Brazil. As part of Brazil's F-X2 program, Saab and Embraer created a full final assembly line for the Gripen E, the F-39, at Embraer's Cavallo Peixoto site. At the same time, Saab Aeronautica Montagens, or SAM, was set up as a Brazilian aerostructures plant responsible for tail cones, aerodynamic brakes, wing boxes, and parts of the front and rear fuselage. Those Brazilian-built structures move into the final assembly hangar, where Brazilian technicians, trained in Sweden and at home, repeat the same choreography, join sections, install systems, test, paint, and fly. Over the life of the program, Brazil does not just receive jets. It builds design, manufacturing, and integration capability. The Gripen Design and Development Network, a hub with modern development tools and simulators, ties Brazilian engineers directly into Saab's digital environment. Colombia's recent decision to buy Gripen E and F follows a similar pattern, airpower tied to long-term industrial and social cooperation, spanning aerospace, cyber, and broader infrastructure projects. This is the model Saab is selling, not just an aircraft, but a partnership. Now bring that logic to a country like Canada. Canada already has a serious aerospace base, Bombardier, major Tier 1 suppliers, MRO hubs, and decades of experience in both civil and military aviation. It is deeply embedded in NORAD and NATO. So what would a Gripen line in Canada look like? Most likely, you would see a final assembly and checkout line hosted by a Canadian partner. Certain major structures would arrive from Sweden and perhaps from Brazil, while Canadian plants would fabricate selected components, pylons, composite panels, harnesses, and maybe parts of the fuselage or wings. A Canadian Gripen engineering cell could focus on Arctic adaptations, Canadian weapons and communications, and integration with NORAD sensors and command networks. Over time, that would give Canada not just aircraft, but an industrial asset, a fighter line capable of evolving with national needs. The catch, as always, is the engine. As long as F414G remains at the core, the most critical component of the jet sits under US export policy. For some nations, that is an acceptable trade. For others, it will be the central political question in any Gripen deal. Step back and look at the big picture. Gripen is small. It is not a stealth giant. It does not carry its weapons in a cavernous internal bay. But it answers a different question. How do we field serious air power, survive the first days of a real war, and still afford the rest of our defense and society? You get a fighter tuned for short highways and cold winters. A jet with a brain built around networks, EW, and smart weapons. An industrial model designed for technology transfer and shared development, as seen in Sweden, Brazil, and now Colombia. For rich superpowers, the F-35 and other heavy stealth platforms may remain the headline answer. For countries that want control, flexibility, and a fighter that can be everywhere the enemy does not expect it, Gripen remains one of the most interesting options on the table. So here is the question for you. If you were planning the air force of a medium-sized country today, would you choose a small fleet of ultra-expensive stealth aircraft or a larger fleet of smart, road-based Gripens, backed by local industry and real autonomy? Let us know in the comments which side you would pick, and which country, in your view, should have chosen Gripen but did not. And if you want to see a dedicated episode comparing Gripen and F-35 for Canada specifically, from costs to basing to industrial impact, make sure you are subscribed. Because that story is coming.